The last portion of this first section, dealing with three-dimensional shapes, is talking about spheres and ellipsoids. And you're going to see a lot of the same properties between spheres and circles and ellipsoids and ellipses in terms of how the pieces are connected together. So just something you want to put up at the top before we jump into all the sphere stuff is going to be the standard form of your sphere or your standard form of your ellipsoid. So real quickly, let's just go about and look at how those would look. So first of all, you know a circle was x minus h quantity squared plus y minus k quantity squared is equal to r squared. Well, the same thing is going to apply with the sphere, only we're going to have that z term added. And usually you'll see the standard form of a sphere written in a couple of different ways. The first way you might see it is x minus h quantity squared plus y minus k quantity squared. So the exact same thing so far as you've seen previously with circles. But then we're going to add this last term, which is z minus l quantity squared is equal to r squared. So you're going to have the exact same format as you had before, only you're going to have this z minus l quantity squared piece thrown in. The other way I've seen it written is because this L usually means length, this isn't really the most fun way to look at it. I've also seen it as just x minus x sub 0 quantity squared plus y minus y sub 0 quantity squared plus z minus z sub 0 quantity squared is equal to r squared. So just be aware that those are two ways that we can look at your sphere being written in standard form. So looking at a couple things here, when we look at a sphere, we know that the sphere has a center right there. This radius coming out, the radius coming out in the z direction, and the radius going straight upward are all identical. So that lends us to our formula for the volume of a sphere to be 4/3 pi r cubed. Now, when we're looking at an ellipsoid, we're going to have three different pieces. We're going to have a piece that goes out along the x-axis, a piece that goes up along the y-axis, and then the piece that comes out three-dimensionally. So we've got three different ways to represent that, possibly three different lengths. So if we're going to go with the volume of an ellipsoid, it's going to look very similar to the sphere, except for it's going to be a times b times c, because we can't be guaranteed that all those lengths are the same. And in fact, if all three of them are the same, then I do have a sphere. Example number 15, we don't need to worry about. We already found the area of a circle with the radius 4. But if we want to find the volume of a sphere with radius 4, all we'll do is we'll apply our volume formula, which is going to be, in this case, 4 divided by 3 times pi times 4 cubed, or 4/3 pi r cubed, which gives us 4/3 pi and 4 cubed is 64. Multiplying all those things together gives us 256 over 3 pi units cubed. Example number 17 we've actually already done before, finding the area of the following ellipse. Example 18, we want to find the volume of the following ellipsoid. 16x squared plus 4y squared plus 64z squared is equal to 64. Where is the ellipsoid centered in space? So the first thing we want to do here is we want to get our ellipsoid into standard form. And just like the ellipse, the standard form of an ellipsoid is when we're equal to 1. So we'll divide everything here by 64. So that's going to give me x squared over 4 plus y squared over 16 plus z squared over 1 is equal to 1. Now if I look at that, I can see I've got nothing in parentheses there. I don't see any x minus 4 quantity squareds plus y plus 3 quantity squareds. There's nothing inside that quantity squared. So this is really x minus 0 quantity squared. So I'm going to be centered at the origin, 0, 0, 0, in three-dimensional space. The next thing that I want to look at is I want to find the volume of this. And my standard form for an ellipsoid is x squared over a squared plus y squared over b squared plus z squared over c squared. Or those a, b's, and c's can be in different places depending on which way is the ellipsoid being stretched. Is it being stretched in the x direction, the y direction, or the z direction? And then we look at major axis as being the longest piece, and so forth. So our standard form for an ellipsoid, or one of the standard forms, is x squared over a squared plus y squared over b squared plus z squared over c squared is equal to 1. So that means each of these values down here, in order for me to find my a, b, and c, I need to take the square root. So right here, the square root of 4 is 2, the square root of 16 is 4, and the square root of 1 is 1. And since I'm looking for the volume here, I'm doing the volume as 4/3 pi ABC for the ellipsoid. It doesn't matter which one is A, which one's B, which one's C, because I'm just multiplying all three pieces together. So it's 4 times 2 times 1. Doesn't really matter the order that I put that. So I'll get 32 over 3 pi units cubed for the volume of my ellipsoid. And then the final thing, writing the standard form of a sphere that has a center at 3, 2, 9 and a radius of 12. Well, at the top here, we said our formula for a sphere is going to be the exact same thing as a circle with this extra z piece added. Notice that this is still r squared. It does not become r cubed when we're a sphere, even though you might think it should because it's 3 dimensions. We're still talking about r squareds in our standard form. So here the standard form of a sphere that has a center at 3, 2, 9 and a radius of 12. X minus 3 quantity squared, since that 3 is tied to the x piece, plus y minus 2 quantity squared, since that 2 is connected to the y piece, plus z minus 9 quantity squared, since that 9 is connected to the z piece, and a radius of 12, which means r squared is going to be 144.